Right, imagine I've got a bag, a box, got 3 red cards, 2 orange cards, all mixed up in there. And I'm going to pick a card at random without looking. So I could ask the question, what's the probability, what are the chances of picking a red? What's the probability, or you can say, what are the chances of picking a red card? Well, there's 5 cards altogether there. And there's 3 red cards. So it's 3 in 5 chance, 3 out of 5. Right. That's the probability of picking a red card. You can convert that to a decimal if you want to, or a percentage if you want to. It's the same thing. These are the same thing. What's the probability of getting orange? 2 out of 5, 2/5. Or you could say 0.4, 40%. But what do you notice about these? They add up to 1. Okay, if you used to add these 2 fractions up, got the same denominator. Add the numerators, 3 add 2 is 5. 5 out of 5, that's a certainty, that's a 1. Also, you notice 0.6 adds 0.4 also adds up to 1. You also notice 60% and 40% adds up to 100%. Alright, 100% means certain. All probabilities add up to 1. If I was to ask the question, what is the probability of getting green out of this bag? No chance. Now, different question. What if I said to you, what's the probability of getting a red? So you take it, yeah. So you've got a red, imagine you've got a red, then you throw it away, and then what's the probability of getting red the second time round? Probability of getting red is obviously, we've done that here, 3 out of 5, 3/5. So imagine you take a red, you got a red, right? Now, what's the probability of getting red the second time round? That's going to be 2 out of 4. 2 out of 4, or if you like, you can call it a half if you want to, yeah? So, probably getting a red and then a red again, you times them. You have to times them. 3 times 2 is 6, 5 times 4, 20. If you want to simplify that then, 3/10, 0.3. So there's a 0.3 chance, 3 in 10 chance of getting a red and then getting a red the second time round. Right. You'll notice that the denominator has gone down. It was a 5 because we had 5 cards, and then we had 1 less, okay, because we didn't put it back in, we didn't replace it. So that's why second time round there's only 4. The denominator is 4 because we're choosing out of 4 cards. But what if first time round we choose a card, have a look at it, take a note, and then put it back in again? Right. So obviously for the first time round it's 3 out of 5, 3 in 5 chance. 3, look, 3 in 5 chance. Remember, look at the card, put it back in again. So the denominator should still be 5 for the second time round, and probability of getting red is going to be 3. In that case, it'd be 3 times 3, 9, 5 times 5, 25. Alright? 9 in 25 chance of getting a red and then a red again. But that's only because we put the card back in before we pick the second card. Now, I just said to you, all probabilities add up to one whole, right? Let's suppose a particular football team, probability of them winning is 0.72, losing 0.1, very unlikely. Draw 0.15, or let's say the match being cancelled for whatever reason. You need to find that. Remember, all probabilities add up to 1. So what you do is, first of all, you add these up, put an extra 0 there because then that'll match up with the number of digits after the decimal point. Add them up. It's like money. This looks like money, 72p, 10p, 15p. Everything adds up to £1 if you think like money, right? But obviously we're not dealing with money. So these add up to 0.97. So 0.97, all of these add up to 0.97, plus that something has to equal to 1. So if you think like money, 97p, add something to give you £1. That's obviously 3 pence, isn't it? But you're right, 0.03. Right, so these now add up to one whole. All probabilities add up to 1. Right, let's suppose this particular team plays 40 games in a season. I want to know how many games are they likely to win. All right, you know this is a pretty good team. They win most of the games because that's tending towards 1, isn't it? There's quite a high chance of them winning compared to losing. All right. So out of 40 games, you'd expect most of the games to be won. But how do we calculate that? Well, what we do is 40 times 0.72. I'm going to use a calculator for that. $28.8. Let's be sensible about this. Let's just round it up. We'd expect this team to win 29 games, 29 wins out of 40. Right. That's just a theoretical probability. But you know what? They could have a very bad season, end up losing every single game. But that is very, very unlikely. All right. And winning every single, it's possible that they can win every single game. That's also a possibility. But in theory, right, even before the season begins, you'd expect them to win around about 29 games based on what's given here. Right, the football manager of this particular team might say, well, the default is 0.72. The default for the probability of winning is 0.72. And then somebody else from the outside comes in and says, well, I think that's too high. I don't believe that's true. Right, so one particular season, they sample 40 games and then they find that there's only 20 wins. Obviously less than 29. They find that there's 20 wins. Now, is that enough to say, well, actually, that is wrong? Maybe they have having a particular bad season. They only won 20 games. Right? You'd expect them to win 29 games, but they only won 20 games. It's fairly close to 29. Is that enough to say, tell the manager, you are lying. What you're saying is not true. Well, maybe not, right? Because 20 is quite close to 29. But let's say in another season, 40 games. They play 40. Sample 40 games. This person samples 40 games, and they find out there's only 3 wins. All right. Now, 3 out of 40. You'd start questioning the manager about that then. And the topic I'm talking about here is not really in GCSE maths. It's more to do with A-level maths. It's called hypothesis testing, right? But I've only said that to you just to get you thinking about what I've just said here. So if the actual number of wins in reality is way less than 29, let's say even more extreme, 1 out of 40, right? Then you could definitely say, go back to the manager and say, well, you know what? The probability of winning should be way less than that. But if the number of wins, the actual number of wins is closer to 29, then you're not really in a position to write them off yet. Right, if I was to carry a proper hypothesis testing for something like this, it wouldn't be as complicated as win, lose, draw, cancel. It'd just be win, lose, or true and false, yes, no, hot, cold, right? Only 2 conditions.